All right, today we're going to tackle a pretty wild idea. What if the entire way we build web applications, what if that fundamental architecture is just, well, broken? And what if there's a much simpler, way more powerful path forward? Let's dig into why this old way of working is holding us all back and what a truly web-native future could actually look like.
Oof, strong words to start with, right? I mean, this quote from DHH, the creator of Ruby on Rails, it's a real gut punch for a lot of us in this industry. Does that sound familiar at all? Spending your days just wiring up forms to database tables? If it does, you are definitely not alone. And the argument here is that it's not really your fault. It's a problem with the actual foundation we're all forced to build on.
So let's get right to the heart of it. Are we, as an entire industry, really spending our time and our talent on the right problems?
I mean, this just perfectly captures that feeling, right? So much of modern development feels less like genuine innovation and more like running on a hamster wheel. We're writing the same controller logic, the same data objects, the same API endpoints again and again and again. But listen, this isn't a failure of talent. It's a symptom of the, honestly, outdated tools we're all stuck using.
So to really get why we're stuck in this loop, we have to go back in time, way back, to before the web as we know it even existed. We need to take a hard look at the decades-old foundations we are still building on today.
And when you look at this timeline, you see this huge disconnect, right? Our core technologies, I'm talking SQL databases and the Model View Controller Pattern, or MVC, they were created for mainframes and desktop apps before the web was even a thing. Think about that. We have literally bolted tech from the 70s and 80s onto this global, hyper-connected system of the 21st century.
And what does that mismatch get us? Well, it gets us what some people call the translation tower. Just think about your average web app. A web address, a URL, comes in. What's the first thing we do? We translate it into a database ID. We use tools called ORMs that basically make a fragile copy of our database inside our code. Every single microservice needs its own special data format, its own JSON contract. You see what's happening? It's just layer after layer of translation, and all that glue code, man, it is incredibly fragile.
And look, this isn't just some abstract academic problem. This complexity leads to very real, very painful consequences. We're talking about nasty bugs hiding in those layers of glue, outages that cost companies billions, and, let's be real, a whole generation of developers just burning out on this mind-numbing, low-value work.
All right, so enough doom and gloom about the problem. Let's talk about the solution. What if instead of constantly fighting the web, we actually started building with it? So what does a truly web-native way of doing things even look like? Believe it or not, that entire translation tower we talked about, it can be replaced by just two simple, really powerful principles. First, we need to embrace a common data model that's actually built for the web, where the links between data are just as important as the data itself. And second, we need a single, uniform way to talk to that data, no matter where it is. And the best part is, this isn't science fiction. These principles are already here, built on web standards that already exist. For the data model, we've got something called the Resource Description Framework, or RDF. Just think of it as a way to describe anything, a user, a product, whatever, using a web address as its unique ID. And for that uniform interface, we have Sparkle. It's basically SQL for the web, a standard way to query and update data using simple web requests. Okay, and here is where the magic really happens. When you use this approach, the complexity just evaporates. The web address, the URI you use in your request, is the identifier in your database. There is no translation. That means no brittle mapping layers, no ORMs to fight with, and no need to create dozens and dozens of temporary data containers just to move information around. It just works. Okay, this all sounds pretty cool from a tech perspective, right? But what does it actually mean for your business, for your engineering team? What are the real tangible benefits here? So what does this actually look like in practice? It means instead of building and maintaining dozens of different custom APIs for every single application, you now have just one. A single, powerful, web-native API for all of your data. Let's actually break this down side by side. Think about when your data schema needs to change. The old way? It often breaks everything downstream. With this new approach, you can just add new kinds of information without blowing up existing apps. And integration costs, they just plummet because you're linking data together directly instead of building these fragile custom data syncing pipelines. But most importantly, your developers are finally free from writing endless boilerplate code so they can focus on what actually matters. This is more than just a tech change. It's a huge philosophical shift. For decades, we've basically shoved our data into boxes that are applications defined. This new approach says, no, put the data first. You design a global, self-describing graph of your data, and then you build applications around it. And why does that matter? Because your data is going to outlive any single piece of code you write, any framework, any team.
Okay, so at this point, you're probably thinking, this sounds great, but wow, that sounds like a massive, disruptive change. So let's talk about the practical side of actually making this switch.
And yeah, this is usually the first question that comes up. And it's true. These technologies aren't as common as, say, SQL or JavaScript. So let's kind of reframe this. This isn't just a technical problem, it's a strategic business choice.
You really have two options here. Option A is, well, the status quo. You just keep paying that CRUD tax of endless boilerplate code and the insane cost of integrating all these different APIs. Or there's option B. You make a one-time investment in learning these standards, and by doing that, you permanently eliminate that entire class of problems. When you look at it that way, the choice gets a lot clearer, doesn't it?
And you know what? The great news here is you don't have to do this all at once. You don't have to boil the ocean. You can migrate step by step. You can start by just creating a read-only semantic layer right on top of your existing databases. This lets new apps see your old data in this new, powerful way. Then, as you build new things, they can write data directly to the new system. And over time, you can slowly and safely retire the old stuff without a big, risky rewrite. Okay, so if getting rid of all that tech debt and making your developers happier isn't enough to convince you, there is one more massive, game-changing reason why this matters right now. And yeah, it has everything to do with AI.
You see, the whole AI agent revolution is happening. But guess what? These agents are slamming into the exact same walls that human developers have been hitting for years. They're trying to navigate this chaotic world of thousands of incompatible APIs, each with its own brittle data contract and login flow. It's just an absolute nightmare for any kind of real automation, where one tiny API change can break the entire chain.
This is where that web-native architecture we've been talking about becomes an absolute superpower. This whole idea of linked data, which is built on RDF, is exactly what AI agents are starving for. Every single piece of data gets a unique web address. The data literally describes its own meaning, so an AI never has to guess what a field is for. And there's one predictable, uniform way to interact with all of it.
And what's crazy is, this vision isn't even new. The inventor of the web himself, Tim Berners-Lee, he described this exact world way back in 2001. A world where machines could coordinate these complex tasks for us because they could actually understand the data they were working with. What sounded like sci-fi back then is now becoming an urgent, practical necessity because of AI agents. So at the end of the day, we have to ask ourselves a pretty simple question. Are we going to keep building on a foundation from the 1970s, just creating more complexity for ourselves and for the AI agents of the future? Or are we going to finally build for the web we have now and the one that's coming? The AI revolution is here. The only question is, will your architecture be ready for it?